Off the coast of West Africa, a tropical wave that meteorologists are tracking under the designation Invest 91L has done something in the last 36 hours that isn't supposed to happen this fast. Sea surface temperatures beneath it are running nearly 1.5 degrees Celsius above the seasonal average, and the system has gone from a disorganized cluster of thunderstorms to a tightening, symmetrical structure with a well-defined central pressure drop. This is the setup meteorologists watch for before rapid intensification, and it's happening earlier in the season and further east than the historical pattern usually allows. Your instinct here is probably that an early season disturbance, this far from land, isn't worth much concern yet. And most years, that instinct would be exactly right. The majority of African easterly waves fizzle out over cooler open ocean before they ever organize into something worth naming. What's different this time is the ocean itself. The stretch of tropical Atlantic this system is crossing, roughly between 10 and 20 degrees north latitude, has been running anomalously warm for weeks, not days, and warm water is the fuel source that turns an ordinary disturbance into something that intensifies faster than forecast models are built to comfortably predict. The setup driving this pattern is what meteorologists call a weakened trade wind regime, combined with reduced wind shear across the tropical Atlantic's main development region, the stretch of ocean between Africa and the Caribbean, where roughly 85% of major Atlantic hurricanes originate. Think of wind shear normally acting like a hand pressing down on a spinning top, disrupting the vertical structure a storm needs to organize. When that shear drops below roughly 10 knots, as it has across this corridor for the better part of 9 days now, the top is free to spin faster and tighter without anything knocking it off balance. That 9-day stretch of low shear, paired with sea surface temperatures sitting at or above 29 degrees Celsius, down to a depth of several dozen meters, has persisted long enough that forecasters have moved this system from a routine watch item to something actively flagged in daily tropical outlooks. The compounding mechanism here is ocean heat content, not just surface temperature. A warm skin of water only a meter or two deep gets churned up and cooled quickly by a storm's own passage, which is normally one of nature's built-in brakes on intensification. But when that warmth extends deep, as satellite altimetry and buoy data are currently showing across this stretch of the Atlantic, a storm can't cool the water beneath it fast enough to slow itself down. And that's the exact mechanism behind rapid intensification events, defined by NOAA as a wind speed increase of at least 35 miles per hour within 24 hours. That's not a gradual strengthening curve. That's a system that can go from a moderate tropical storm to a major hurricane in a single day, leaving evacuation planners with far less lead time than a slower developing system would allow. In terms of scale, current model guidance is showing a plausible track that could bring this system into the eastern Caribbean within 5 to 7 days, with rainfall potential in the range of 150 to 250 millimeters over a 24-hour period should it interact with any of the mountainous islands along that path, terrain that tends to wring additional moisture out of a tropical system through forced lift. It's worth being honest here about how unpredictable the hyperlocal picture still is this far out. One island chain could see catastrophic flash flooding, while another just 100 kilometers away sees a glancing, almost unremarkable pass, and at this range, no model can reliably tell you which is which. This kind of early, fast-developing Atlantic threat isn't unprecedented, and the historical comparisons are worth sitting with. In 2023, Hurricane Otis intensified from a tropical storm into a Category 5 hurricane in under 24 hours before striking Acapulco, a rapid intensification event that caught official forecasts badly off guard and contributed to dozens of deaths and billions of dollars in damage. Hurricane Ida, in 2021, underwent a similar rapid strengthening phase over anomalously warm Gulf waters before making landfall in Louisiana as a Category 4, knocking out power to over 1 million customers for more than a week. And going back further, Hurricane Wilma in 2005 still holds the record for the fastest pressure drop ever recorded in the Atlantic Basin, intensifying explosively over water conditions that meteorologists at the time described as unusually primed. Each of these events shared the same underlying signature: deep, unusually warm ocean water paired with weak wind shear, allowing intensification to outrun the forecast models trying to track it. The honest range of outcomes here splits fairly widely. In the milder scenario, This system encounters a patch of Saharan dust, or increased shear, as it crosses the central Atlantic, both of which can choke off organization, and it weakens into an unremarkable rain event by the time it nears any landmass, similar to how a number of promising August waves dissipated harmlessly in both 2022 and 2023. In the more serious scenario, the current low shear, high heat content environment holds through the system's westward track, and it undergoes another rapid intensification phase as it approaches the Lesser Antilles or the Eastern Caribbean, arriving as a major hurricane with less warning time than residents are used to. Islands with steep volcanic terrain, like Dominica or parts of the Windward Chain, would be at heightened risk, specifically because that terrain amplifies rainfall totals well beyond what flatter islands nearby would experience from the identical storm. What forecasters genuinely cannot tell you at this range is the exact landfall location, the exact wind speed at landfall, or which specific coastal community will see the worst of it. Those details typically don't stabilize until a system is within 48 to 72 hours of any coastline. What they can responsibly flag right now is the environmental setup itself, the ocean heat content, the shear pattern, and the historical tendency for systems forming under these exact conditions to intensify faster than average. That's a meaningfully different, more honest statement than predicting a specific outcome for a specific town 9 days out. It's worth mentioning, as a genuinely active and still debated area of climate research, rather than a settled driver of this particular system, that warmer global ocean temperatures are associated in multiple peer-reviewed studies with an increased frequency of rapid intensification events across the Atlantic basin over the past 2 decades. Researchers continue to debate the precise magnitude of that trend versus natural multi-decadal ocean cycles, and no credible scientist would attribute any single storm's behavior directly to long-term warming. But the broader pattern of more frequent rapid intensification is one meteorologists are watching closely across multiple storm seasons, not just this one. If you live anywhere along the Eastern Caribbean or Gulf Coast, there are concrete steps worth taking now rather than waiting for a named storm to force your hand. Keep your phone's wireless emergency alerts active, since rapid intensification events can shrink your genuine decision-making window from days to under 24 hours. If you're in a flood-prone area, know now, not later, where you'd move a car or store important documents, since floodwater moving at even 15 miles per hour can float a vehicle off a roadway, which is exactly why driving through moving water during any tropical system is never worth the risk, regardless of how shallow it looks. Check on elderly or mobility-limited neighbors, specifically in areas with a history of power loss, since extended outages during a major hurricane can stretch past a week, as Ida demonstrated in Louisiana. And if you're anywhere in the potential path, have a battery-powered radio and backup charging option ready now, because cell infrastructure is often the first thing to fail once sustained winds cross roughly 75 miles per hour. The core lesson here isn't that this specific system is guaranteed to become a major hurricane. The honest data doesn't support that level of certainty yet in either direction. It's that when ocean heat content runs this deep and this warm, the danger doesn't announce itself gradually, the way older forecasting assumptions once suggested. It can compress days of expected warning into hours, which means the moment to prepare is now, while the system is still a data point on a satellite loop and not a name on an evacuation order. If you want to catch the next pattern shift before it escalates, instead of scrambling once it's already a headline, that's exactly what this channel tracks storm by storm. Stay ahead of the water, and stay ready before the ocean tells you it's too late.